Properties of rhombuses and 3 theorems. We're at 6.4b with 9 previous videos for Chapter 6 that are in the geometry playlist if you've missed them. Okay? So far in this chapter, we've learned that parallelograms and rectangles are special quadrilaterals. A rhombus is another special quadrilateral. A rhombus is a quadrilateral with 4 congruent sides. So we can see the congruent marks on the sides. This is rhombus ABCD. Here's our 3 theorems. For the properties of rhombuses, our first one says if a quadrilateral is a rhombus, then it's a parallelogram. It's got 4 congruent sides, so we know it's a rhombus. Well, then ABCD is a parallelogram. We can write geometric notation, rhombus, therefore parallelogram. Our next one says if a parallelogram is a rhombus, then its diagonals are perpendicular. We can see 4 congruent sides, so we know it's a rhombus, and we can see the diagonals, and they are perpendicular. AC, segment AC is perpendicular to BD. And we can write in geometric notation, rhombus, therefore diagonals, perpendicular. Our last one says if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So this diagonal BD is bisecting here, and AC is a diagonal that's bisecting these and these. See? This and this. So we get angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, angle 5 is congruent to 6, and 7 is congruent to 8. We can write geometric notation, rhombus, therefore each diagonal bisects opposite angles. All right? So here we have a paragraph proof with theorem 6.4.5, the one we just talked about, the diagonals bisecting the pair of opposite angles. So it's given that JKLM is a rhombus. We see 4 congruent sides. We need to prove that this diagonal JL bisects KJM, that's this one down here, and KLM, that's this one up here. We also need to prove that KM, this diagonal, bisects JKL here and JML here. So here's our paragraph proof, and I hope you can follow me. Remember, I always write my reasons in brown, okay? So the statements are in black and the reasons are in brown. Well, since JKLM is a rhombus, then JK, this one, is congruent to JM, this one. See, all the sides are the same length, they're congruent. And KL, this one, is congruent to ML, this one. That's by the definition of a rhombus. And by the reflexive property of congruence, segment JL is congruent to segment JL. This side, JL of this triangle, is congruent to JL of this triangle. That's the reflexive property. Therefore, triangle JKL, this one, is congruent to triangle JML, this one, by side, side, side. We know that's congruent to that, and this is congruent to this, right? So we have 3 sides that are congruent to each other. That's side, side, side. Then angle 1 is congruent to angle 2 down here. And 3 is congruent to 4 by CPCTC. Congruent parts of congruent triangles are congruent. So we proved that they were congruent by side, 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 so we know all the angles are congruent too. So segment JL bisects angle KJM, that's this one down here, and angle KLM, by definition of an angle bisector, and by similar reasoning, all of this, KM, this diagonal bisects angle JKL and angle JML over here, okay? So like a rectangle, a rhombus is a parallelogram, so we can apply the properties of parallelograms to rhombuses. We can use properties of rhombuses to find measures. RSTV is a rhombus, and we need to find VT. This right here is what we're looking for. Well, it's telling us that ST is 4x plus 7, and RS is 9x minus 11. And VT, to find it, we do ST equals SR. That's the definition of a rhombus. These are all congruent, right? We can put our congruent marks because it told us it was a rhombus. So if this 4x plus 7 is congruent to 9x minus 11, we've got our equation. We can subtract 4x from each side, eliminate it, and get 7 equals 5x minus 11. Solving for x, we add 11 to both sides and eliminate this 11, and we get 18 equals 5x. We divide both sides by the coefficient 5, and we get x is equal to 3.6. Well, now that we know what x is equal to, we can put it in here. And if all the sides are congruent, and we know what these are equal to, then we'll know this one, won't we? So, VT is equal to ST. We know ST now, right? Because we can plug in, substitute in the x. Well, VT is equal to 4x plus 7 then. See? We've got congruent sides. We substitute the 4x plus 7 for ST, and we put in the 3.6 for x, and we find out that VT is 21.4. Okay? Substituting the 3.6 for x and simplifying. All right? We got one last short one. Look at this diagram. We've got a rhombus, and this angle right here is y plus 2 degrees, and this angle, SWT, inside of right up here, is 2y plus 10 degrees. RSTV is a rhombus. I meant to write that in red, so I left it blank when I was writing with the black pen. Sorry about that. We need to find the measure of angle WSR. WSR. We need to find this one right here. So that tells me if we can find this one, and this is bisecting it, it'll be equal to that one, won't it? So the measure of angle SWT is 2y plus 10 degrees. That's 90 degrees. Because if it's a rhombus, then the diagonals are perpendicular. So that's got to be 90, right? So we can set 2y plus 10 to equal 90. We can subtract 10 from both sides and get 2y equals 80. Divide both sides by the 2 coefficient and get that y equals 40. Now we can put 40 in here for the y, and we'll get that it's equal to 42 degrees. See? Okay? So make sure you write down all these theorems, because you're really going to need them, all right? So our next video is properties of squares. That's 6.4c, the third video for 6.4. After that, we're going to make some rhombuses with a compass, okay? So have a great day, like always. Check out my Teespring stuff. I've got some cute shirts and mugs and stuff. And don't forget, you can DM me on Twitter if you have a question. And I'll see you next time. Bye. Hit that like button.